Hello there, welcome back to the new lecture. So in this lecture we are going to discuss about water supply pipe sizing as per International Plumbing Code. So let's start. So here you can see we have already drawn the water supply single line layout. Okay. So now we are going to start the pipe sizing from the last floor, from the 8th floor. Okay, let's see. So come here first, because 8th floor to 2nd floor is a typical floor, so we are going to start the pipe sizing from here. Okay, so let's see. So for pipe sizing as per International Plumbing Code, first you have to see this is our cold water line, this green, this is our domestic water or cold water you can say, and red color is our hot water line. Okay, so how to do the pipe sizing? So first of all, you have to remember that for gravity fed water supply system, the recommended velocity, how much velocity we have to take. So the recommended velocity can vary slightly based on whether the water is cold or hot due to differences in usage pattern and thermal expansion consideration. So in general practice, if you are doing pipe sizing for cold water supply, like for green color, which is our domestic water, and this flush water, generally inside this pipe we have a cold water only, normal water, cold water. So the recommended velocity for cold water in gravity fed system is typically between 2 to 4 feet per second. Okay, you have to consider the velocity between 2 fps to 4 fps. Okay, so this range ensure efficient flow while minimizing issues such as pressure loss, potential pipe erosion and noise. Okay, so better is to maintain the 2 fps, select the minimum velocity whatever it is given, 2 fps to reduce the noise, and as per 2 fps you have to do the pipe sizing of cold water. Same way if it is a hot water, so for hot water the recommended velocity is slightly lower, usually between 1.5 to 3 per 3 fps, okay, feet per second. So the reduction account for the thermal expansion of the pipe and the needs to prevent excessive wear and noise, as hot water can exacerbate these issues na? So for both pipe, either it is a hot or cold, I'm just taking the average value 2 fps. So we have to take the velocity 2 feet per second. As per that we have to do the designing. Okay, so let's see. I'm just talking about gravity pipe. Okay, is it clear? Gravity fed water supply pipe, because see the pipe here we are running two pipe, one is domestic and second one is flush water pipe. So from the OHT tank we are running the pipe na, we are supplying the water to each and every fixture. So this pipe is called as a gravity fed water supplies pipe, and the pipe which is coming from the UGT tank, see this pipe from this OTS, means from this shaft you are just taking that pipe here. So this is your pumping main pipe. So while doing the sizing for pumping main pipe, we have to take different velocity. Okay, remember this thing that I will explain you, but first let's see how to do the gravity fed water supply pipe sizing. So we are going to start from here. Now for this, see, first I will start from here. Let's say here the cold water we are supplying to the water closet for washing purpose, and see the cold water we are supplying for flushing purpose also, this flush water pipe. So for both, here we have a water closet fixture. So see, here I am opening the International Plumbing Code. I will share you this code. So in International Plumbing Code, for water supply pipe sizing, you have to open the page number 164. You can see Appendix E, sizing of water pipe system. Just scroll down, here you will get the option. See, table number E, what is written here? Load value assigned to fixture. So first thing na, based on your fixture you have to calculate the water supply fixture unit. What is actually water supply fixture unit? Water supply fixture unit is a measure used in plumbing design to represent the load that a specific fixture imposes on a water supply system. Okay, it accounts for both the water flow rate and the usage frequency of the different fixtures. So the concept help in determining the necessary pipe sizes, water pressure and capacity requirement to ensure adequate water distribution throughout a building. So each type of fixture such as sink, toilets and shower is assigned a specific water supply fixture unit value based on its water uses characteristics. So can you see, based on fixture type, here occupancies is also given. You are using this fixture for private or for public use. As per that, you will get the water supply fixture unit for cold water, for hot water, both. Once you will get the fixture unit, so based on this water supply fixture unit, in the next table you can easily calculate the water demand value in GPM, gallon per minute, or in cubic feet per minute. So once you will get the water demand, now here you can see, just scroll down, we have a graph to find out the pipe sizing. In this graph, try to understand this vertical line is our water flow rate in gallon per minute, you can see, and here the pressure drop per 100 feet of tube is given. You can see this horizontal inclined line is representing diameter in inches, vertical inclined line is representing velocity in feet per second. So based on water demand and water velocity, you will get the diameter from this table. So this graph, when you see this graph, here it is written, this chart applies to smooth new copper tubing with recessed solder joint, okay, and the next second chart applies to smooth new steel fairly smooth pipe. So okay, I am selecting this fairly smooth, and as per that, suppose new steel, which type of material you are using, that as per that you have to do the pipe sizing, okay. So 1 fps, 2 fps line, 3 fps line, 4 fps, and here you can see the diameter is given. So let's see, we are going to start. So first I want to do the pipe sizing for this one, let's say for water closet. So which type of water closet it's, suppose here I am assuming this is our flush tank type of water closet, and see where we have placed in the bedroom. So the water closet here which we are using is for public or private use? Private use, because in each and every bedroom we have placed one toilet, bathroom group is given in that water closet. So this is for private use. Or which type of water closet? Because we have a different types of water closet, flushometer type, okay, flush valve type, flush tank type. So I am assuming here, suppose our water closet is of flush tank type and it is for private use. So let's see now, open it. So first you have to open, okay, first open the load value on this table number 103.3. From here you have to calculate the water supply fixture unit based on your fixture. So which type of fixture? Water closet. So where it is here, so we have a different types of water closet. You can see in this type of supply control it is written. So in our case, what I am assuming, my water closet is flush tank type, but it is for private use. So go for this one, water closet private flush tank type. So you can see here for cold water, how much fixture unit is given? 2.2 water supply fixture unit. Here hot water fixture unit is not given, because we know that for water closet we are not supplying hot water. Hot water we are supplying in shower or in wash basin area, okay. So that is why it is not given here. Only we are supplying cold water here. Flush water or fresh water we are supplying for flushing purpose, and domestic water we are supplying for washing purpose, okay. So water closet we have flush tank type private. So see how much for what water supply fixture unit is showing, 2.2, okay. Now in the next table, based on that water supply fixture unit, you will get the water demand here. In the first column you can see the water supply fixture unit is given. So we have got 2.2, means near about 2, let's say, okay. So see for 2 water supply fixture unit, how much here the water demand is showing in gallon per minute? 5 GPM. So once you will get the water demand 5 GPM, just scroll down, open the chart, this second chart, okay. For steel I'm using 5 GPM. Where is 5 GPM? I'm using here, so you can easily understand, okay. Let's say 5 GPM line. See in the y axis, this is our flow in gallon per minute. So here we have a 5 GPM. Now you can see the vertical incline line is your velocity line. It is written velocity in feet per second. So how much velocity we have to maintain? I have already discussed with you, if you remember, that the recommended velocity for cold water in gravity fed system is typically between 2 to 4 fps. So we are assuming minimum 2 fps. As per 2 fps, we have to do the pipe sizing. So this is our 2 fps line, can you see? And here we have a 5. So just trace both of them. 5 GPM line, draw one line here. See, both are intersecting in this point. Where is 2? See, this is our 2 fps line, velocity line. So this is both velocity and flow are intersecting here in this point. So you can see the pipe size is given. How much pipe size? This horizontal vertical line is your pipe diameter of pipe in inches. So when you see here, we are getting 1 inch diameter pipe size. It means just open it and here write down the pipe size for this one and for this one. How much? 25 millimeter in mm. In inches is 1 inch. So 1 inch is equal to near about 25 mm. So I am using the leader line command, LE enter. Now but before that, just change the layer as a text and now use the leader line command, LE enter. Draw one line here. Okay, then right click, repeat leader line and draw one line here like this on your ortho mode. Again on and write down the size whatever you have got. Now I am using the mtext command, T enter. How much size we have got? So I want to show the diameter symbol here. So okay, from the insert panel, see the symbol here. You have, for diameter, you have to select the shortcut percentage %C, or otherwise directly hit on that, you will get the diameter symbol here. Now how much size we have got? 25 mm. So write down the size and change the size of this text. Let's say 200. Enter. Then hit inside the command. So I am just suppose the size of text is so high, so suppose let's say 100. 100 is enough. Just select it, move it little bit and place it. Okay, so for this pipe size we have got 25 mm. Same way here also we have got the same pipe size, 25, because both water we are supplying to the water closet. So I have told you how to do the sizing. Now come to next. Here also same pipe size you will get for this one and for this one. So see what I am doing. Select it, use the mirror command, MI enter, mirror it same size here. You want to erase the source object? No, just leave it. Same now. Select this one also. Use the mirror command. No, I don't want to erase the source object. Use the move command. Place it here. Just use the leader line command, LE enter. You can just give the size like this on your ortho mode. Here I am writing the size, okay, of your ortho mode and place it. Okay, so we have got. Now come to from here. Suppose here we are supplying cold water to the shower and hot water also we are supplying to the shower. So what is the size of this? So based on your fixture is shower. Okay, open the and see. First of all, we need here what? Water supply fixture unit na for shower. Which type of shower? See here the fixture in the first column is shower head. Okay, so here we have two options, for public or for private. So here actually when you see na, this is a bedroom area in hotel building. So actually here the shower which we have placed is for private use. Okay, so the shower head for private. See the fixture, water supply fixture unit is given for cold water is 1. Same way for hot water is also 1. You can see for both fixture unit is 1. Now as per this one fixture unit, when you scroll down the next table, for one fixture unit water demand is showing how much? For hot and cold 3 GPM. Okay, now open the chart, second chart for steel pipe and see. Here I am just deleting this, just erase it. Come to next one. How much? 3 GPM. So see, and what I am assuming the velocity I am just taking for cold water also between 2 to 4 fps, so I am assuming 2 fps. Okay, same way for hot water, if you remember, I have told you the recommended velocity for hot water is between 1.5 to 3 fps. So for both I am using 2 fps only, average value. So 3 gpm water demand which we have calculated, and velocity 2 fps. Where is velocity line? Here, see, both are intersecting in this point. This is your point. So where you can see the size is 3 by 4, means 3 by 4 inch means 20 mm. Okay, just go through that and give the size. So here I am writing the size, leader line command, the pipe sizing, show it like this. Again repeat this one also same, and select this, use the copy command, co enter. So for shower, cold and hot water pipe size we have got 20 mm, so I have written here 20 mm. Okay, now same way this pipe size, the pipe which we are supplying cold water to the wash basin or hot water to the wash basin. So what is, see here what we are doing, don't need to drop the pipe here, actually we are dropping the pipe, or okay, just no problem. If you have dropped the pipe here, no problem, from here also you can drop, otherwise. Okay, now see, the next thing is what, we have to do the pipe sizing for wash basin. See the water which we are supplying, hot and cold water both for wash basin. Okay, so here you can see just what is the water supply fixture unit we have to take for wash basin. Here I am showing you some pipe sizing. Now you can easily do for each and every fixture. So see, wash basin means laboratory where it is for private use. Okay, see, for both water supply, means for cold water, hot water, both fixture unit showing 0.5. So as per 0.5 you will get the demand. So for water fixture unit is started from 1. So for one water fixture unit 3 gpm water demand, so we have got 0.5, so near about 1.5 demand. Okay, 1.5 gpm. So as per 1.5 gpm and 2 fps we have to do this sizing. So where is 1.5 gpm? 1.5 gpm, let's say here. Okay, and draw one line. Where is 2 fps line? Here. See, as per that the pipe size is, always select the greater size, so it is showing half inch, means 15 mm pipe size. Okay, so write down here the pipe size which we have got, use the L leader line command. So this pipe size I'm using, write down the size here for cold and for hot both we have got 15 mm. So use the copy command, place it here and give the size 15 mm. Okay, same way. Okay, we have done this, and this pipe size is also, see, this is also a 20. Okay, you can just take and give the size as a 20 for this pipe. Now the next thing, okay, this one is about 20 mm, and this, the branch pipe which we are taking, which we are supplying to water, this is 15 mm. Now I want to find out the pipe size for this section. For up to here is 20 mm, but again for this one, before supplying the water to the wash basin, here because the water is high, so the pipe size may be increased, so you have to add the fixture unit. For shower fixture unit we have got 1, and for wash basin 0.5, I think, no, 1 0.5, add both of them, so how much you will get? 1.5 fixture unit. Okay, you can see it is written here clearly everything. Okay, see, for shower we have got, you have to add the fixture unit based on that whatever size you have got. See, for shower head, for private 1, for cold water, for hot water also, and for laboratory fixture unit for private 0.1. So when you add 1.5, so as per 1.5 fixture unit, how much flow it is showing? 1.5 is coming between 1 to 2, so it means we have to take the demand value between 3 to 5, means 4 GPM. So okay, open the chart, and as per 4 GPM, where is 4 GPM line? Here, just draw one line, and velocity 2 fps for gravity pipe. See, you will get the pipe size here, how much it is showing. So you can go for maximum, but here when you see na, the nearest one is 3 by 4 inch. So just select, because this is the water supply line, so okay, here you can go for minimum diameter also. So the when you see the this point is closer to 3 by 4 inch, so you have to select this size, means 3 by 4 inch means how much? 20 mm pipe size. Okay, or you can go for 25 also. Actually 4 GPM we have got now, it is coming between 1 to 3 by 4, so it is depend on you. You can go for 20 mm because exact size is showing 20 mm. So here I am just going for 20 mm. Suppose this section size we have got how much? 20 mm. I am writing here. Use copy command and write down. Okay, same way when you are supplying water, so this pipe is coming from the OHT tank, here some amount of water, so I want to do the pipe sizing for this section. So you have to add the fixture unit for water closet also now. So 1.5, and for water closet how much fixture unit we have shown? See now, 1.5 means 0.5 for laboratory, 1 for shower, and for water closet if you see here it is given for private you flushing 2.2. So 2.2 plus 1 for shower, 0.5 for wash basin. So we have got 3.7 fixture unit. So as per 3.7, when you see now, so near about 7 GPM. 3.7 is not given exact, it's coming between 3 to 4, so I'm taking 7 GPM water demand. So as per 7 GPM, when you scroll down, see now you have to do the pipe sizing. So just delete this all and see where is 7 GPM. Here, okay, this is line, draw one line, and where is 2 fps? Here. So both are intersecting in this point. It is coming between 1 inch to 1 next size is 1 by 4 inch. So it means what size of pipe we have to select here? 25. Okay, or you can go for 32 mm pipe size also. But when I'm selecting the larger size, so what happened? This is the water supply line. If you are going for because it is coming between this. Now the question is, we have to select the 1 inch pipe size or 1 by 4 inch. So it is depend on, remember, always for water supply line you have to select the minimum pipes. It is better. Why? Because here we need pressure, na? But in our condition, this is our water, gravity water, already we are getting gravity pressure. Okay, so always for water supply go for this one minimum value, or otherwise you can also select this one also. So it is depend on you. So between 1 to 1 by 4 inch, so let's say I am using suppose 32 mm next size, 1 by 4 inch. I am going for larger pipe size. Okay, 32 mm pipe size we got here, total main pipe size. This was our main domestic water supply pipe. How much? 32. So use the leader line command, draw it same way. I think here also you will get, use the mirror for this line also, same pipe size we get na. Copy, give the, so where you want to write, so let's say I am writing, don't need to write here, I am using leader line command. This pipe size we have got how much, whatever you have got now, write down the size here. 32 mm I am just using, but you can go for 25 mm also, but I have taken the larger size. Okay, so the main pipe size is also 32. After supplying some amount of water in the water closet for washing purpose, again the size will reduce to 20 mm. So you can go for 25 mm. So better is to select the minimum size, as I told you, because here for water supply line always you have to go for, if suppose let's say your pipe sizing is coming between 32 to 25, so always select as a minimum size, because we need pressure here in case of water supply system. But for drainage system you have to go for larger size. Okay, okay, now it is 25. Same way for flush. Okay, 25 mm. Now come and give the sizing for this one also. So first select same sizing, I'm using the mirror command, and give the size here. Okay, same way here also we have wash basin, select it, use the mirror command. No, I don't want to erase the source object. Here you can give it like this. Now for this line 25, same way here we have got, use the mirror command, see the pipe size, main pipe size I have given here. Okay, now if you want to do the riser pipe sizing, suppose the vertical pipe which is coming from the OHT, what is the size of this pipe? So it is totally depend, because here we have a 8 floor, we are doing the pipe sizing for in the floor plan. But for riser pipe you have to add all the fixture which is coming from 8 to, because 8 to second floor is typical. So 8, 7th floor, 6th floor, 5, 4th floor, 3rd floor and 2nd floor. Total we have a 7 floor. Okay, so we have done. You have to add each and every fixture unit. So here you can see, if you remember, I have told you the total fixture unit when you add wash basin fixture unit and this one shower and water closet. So we have got 3.7 fixture unit. So if you multiply 3.7 by 7th floor, okay, so you will get around 25.9 total fixture unit. Okay, I'm talking about this domestic water pipeline. For each floor 3.7 fixture unit when you add all the fixtures. So total we have a 7 floor which is typical. I'm doing the sizing for riser. So we have got 25.9. Just add it and see. So as per 25.9 fixture unit, how much demand now? You have to check the water demand value, 25.9. So let's say 21.5 GPM water demand. Okay, 21.5 or near about 22 GPM. Open the table, where is 20? So 20 is coming here, let's say 22 is near about here. Draw one straight line, both are intersecting in this point. So you now see the pipe size, we have to select 2 inch, means 50 mm pipe. Riser pipe size is 50 mm. Okay, now use the ladder line command and give the size. The pipe, riser pipe, just give it, and here you can write down the use the mirror command, mi enter. I'm just writing here, erase the source object, no, copy this. So this riser pipe size is around 50 mm, we have got 2 inch. Okay, is it clear? So in this way generally we have to calculate the riser pipe size. So for riser pipe you have to add all the fixture unit, but it is up to 2nd floor, because from here the pipe size which is the pipe which we are diverting from here, this pipe size is also same. Okay, I'm writing here 50 mm, this domestic pipe size is showing 50 mm only. Just you can just write down this all pipe and just increase the arrow size here 200. Double hit on this arrow and close this. Double hit on this ladder line and just change the diameter as a size 200. and then write down the size, whatever it is, 50 mm. Okay, so from this first the ceiling level of first floor, this is our first floor ceiling level. From here we are diverting the pipe. So for this pipe, size is 50 mm. Write down and then select it, copy each and every riser, just copy it. Clear? So pipe size we have got 50. Same way now for flush. So here for flush you can see for water closet fixture unit is around 2.2 G, 2.2 water supply fixture unit for water closet. So here we have total 7 floor, which is typical is 2.2 into 7, 15.4 water supply fixture unit is coming. For riser, when you're doing the pipe size, for riser pipe size, so you have to add each and every fixture from 8th floor to 2nd floor. So 15.4. So as per 15.4, how much water demand? So where it is 15.4, near about, so 18 GPM, let's say. So for 18 GPM we have to do the pipe sizing. See, just delete this off. Where is 18 GPM? 18 is coming near about 10 here 20. So 18 is suppose here. Draw one line. See, both are intersecting here. 2 FPS line, 18 GPM. So near about what? This pipe size, it is also 1.5 inch. So first you have to see 15 is coming between this line. So better is to select this one. Okay, 1.5 inch means 40 mm pipe size, na? So for flush riser pipe size we have got 40 mm. So in this way generally we have to do the pipe size. I hope now all of you understood this thing. So it is very easy. Just try to understand the concept and write down the value which we have got here, 40 mm. Okay, now copy this all size for each and every toilet. So how to copy? Just select it and copy it. Select the ladder and text everything from the drawing. Okay, whatever we have done here. Then finally, after selecting this each and every size of pipe, use the copy command, CO, enter, specify the base point as this OTS center point and copy it here in each and every row, because it is a typical, na? Is it clear? So in this way generally we have to write down the here also. 1 minute, na? Use copy command, copy it here, here and here. So now I hope that all of you understood this thing. Clear? Here you can see we have forget to copy the arrow. Show the arrow here like this and use copy command, CO, enter, place it in each and everywhere. 25 mm pipe size, this one. Is it clear? So here we have done the pipe sizing for 8 to 2nd floor. Even riser pipe also I have shown. Now you have to come into the first floor and just do the pipe sizing. It is very easy. Based on your fixture, you have to do the pipe sizing. Okay, so that I will explain you. Now I think all of you can easily do it, this pipe sizing for urinal, for wash basin. Okay, same pipe size you will get. So this is all about the water supply pipe sizing. I hope all of you enjoy the session. See you in next one.